Okay, here are some homework problems, exercise set problems for section 1.4. On this problem, we're evaluating this function f of x equals 4 plus 8x. Part A, what is f of 3? Just put 3 in for x. It would be 4 plus 8 times 3. And you get it. F of negative 2, just put negative 2 in for x and work it out. F of a plus 1, you put the a plus 1 in there for x, and you would have 4 plus 8 times a plus 1. Distribute the 8 across, and then combine like terms, you get 12 plus 8a. Down here for problem 3, we have this expression, or this function that we want to evaluate. Put the negative 2 in for x, and we would get negative 2 over negative 2 squared, which is 4, plus 1 is 5. So we'd have negative 2 over 5. We could do this on Excel as well. If we go to any place that we can just type numbers in, like let's just say right here where data points are, or if you want more significant digits, go here somewhere, and we can just type in equals, plugging in the negative 2 in for x. It'd be equals negative 2 divided by parentheses, and then I'm going to do parentheses again. I'm doing parentheses around the whole denominator, then parentheses, negative 2, close parentheses, shift 6 for the caret up, squared, plus 1, close parentheses around the bottom, and we get negative 0.4, which is the same as negative 2/5. Same way with the negative 5, all we would do is replace, for this 5 right here, just put a 5 in everywhere there is for x. So I could just go right back here where I was and replace that negative 2 with a 5, and also up on the top with a 5. And that's what that expression is as a decimal evaluated at 5. Okay. Putting in the 2x plus 1, I would, everywhere there's an x, it would be 2x plus 1 over the quantity 2x plus 1 squared plus 1, and then you could FOIL that together and so on. Going to this one, 5, one technique of controlling cancer is to use radiation therapy. After such a treatment, the total number of cancerous cells in thousands can be estimated by this function right here. Well, that's a quadratic function, so we can use our quadratic sheet, where t is the number of days after treatment. So n stands for the number of cancerous cells in the units of thousands, and t is the number of days after treatment. It says how many days after treatment does it take to eliminate all the cancer cells? Well, when they're all eliminated, their number would be 0, so you put 0 in for y. So you really just go to the quadratic sheet, put in your a, b, and c, put 0 in for the y value, and you'll get your answer. And then how many cells remain after 2 days? Well, that's putting 2 in for t. In function notation, we would write n of 2 equals negative 2 squared, and so on, like that. That's all there really is to that. Putting the 2 in there and then just evaluating it. You're just putting the 2 in for x on that quadratic. So that's 5. And 7, here's another quadratic equation, and you get this this equation right here, and it says what is the height of the ball after 15 seconds? Just put 15 in for t. Again, I would just use a quadratic sheet. When does it hit the ground? Just put 0 in for the y. This is value right here is your initial velocity. That was the 250 feet per second. This is its initial height. That was the 1285. And this is due to gravity right here divided by 2. That gives you the negative 16. So that's 7. And then 9, that's a piecewise defined function. It says, what is p of 3? Well, p of 3, you look where the 3 falls. Okay, this is an x value. P of 3 means p of x. P of x. The 3 is going in for x. Well, which one of these 3 things do we use, the top, middle, or the bottom? Well, 3 is between 0 and 10, so we would use the top one. You put 3 in for x, so that would be 3 squared, we just would work this out. Let's tell you what, let's do this on the quadratic sheet even. We can go to the quadratic sheet and put in our coefficients of negative 1, 0, and 95, and then all we're doing is we're putting 3 in for x on that. So down here where we can put it, well, we can even put an x value in here. If I put 3 in for x, I get 86. And see, putting 3 in for x, 3 squared is 9, the negative 9 is negative 9, and negative 9 plus 95 is 86. P of 10, well, see, where does the 10 go? 10 is included up here because it says x is less than or equal to 10, and greater than or equal to 0, but it includes the 10, but 10 is also included down here. So you have to evaluate 10 in both places, the top and the middle. So if I put 10 in here, 10 squared is 100, and negative 100 plus 95 is negative 5. Put 10 into this one, and you get 40. 40 minus 45 is negative 5. So both places give you the same thing, negative 5. P of 15, well, it's defined here in the middle, and it's also defined here because it says less than or equal to, so it includes the 15, and it says x is greater than or equal to 15, so it includes it too. Putting the 15 in this, 4 times 15 is 60. 60 minus 45 is 15. Okay, 15 times 4 is 60. 60 minus 45 is 15. Putting the 15 in here, we get 30. So you get two different answers. So now, is this thing a function? Well, if the 15 would have given us the same answer in both places, just as the 10 did, then it would be a function because every x gives you one y. But because this one particular x, 15, gives you different values, it is not a function. And see the same type of thing here with 8. 5 is defined in both places. 3, you would just put it in the top one. You get 3. Put 5 in. You get 5 on the top, put 5 here, and 5 times 0.5 is 2.5. 2.5 plus 3 is 5.5. So you don't get the same thing, so this thing is not a function. 8, with 8 you'd have to evaluate it in both places, the middle and the bottom, and you get 7 on both of those places. 13, well, 13 is only in one place, that's this place right here, and see there's nothing to put in for x, so you just get 7 no matter what you substitute into x for this bottom equation, whether it be 8, 9, 10, 11, 12, or 13, you get 7. So A of 13 would be 7. And that's pretty much it with section 1.4. So again, here, is this thing a function or not? No, it's not a function, this one, because 15 did not give you the same answer in both places. 10 did, but 15 didn't. Okay, we'll stop there.